Alright, let's have a look at an example using the reduction formulae that we looked at in the last video. This is a simplification question. It says to simplify cot of pi over 2 plus theta multiplied by cosec of pi minus theta divided by sec of 2 pi minus theta. Now I've drawn a little cast diagram on the right hand side just to help me along, plus a set of questions that you must take note of every time you do a simplification or a proof involving reductions. Okay, so let's have a look. When you're doing a question like this, you need to just go one reduction at a time. So let's first look at cot pi over 2 minus theta. So I'm going to ask myself these questions that I've written on the right. The first question I ask is, what quadrant does this angle lie in? And we know that pi over 2 plus theta lies in the second quadrant. Then I need to check, is cot positive or negative in that quadrant? Well, the cast diagram tells me that only sine is positive in the second quadrant. Therefore, cot is not positive because cot and tan go hand in hand. So we know that it's going to be negative, so I can put my negative down so long. Then, is there a name change? Well, the moment I'm dealing with pi over 2 plus or minus, automatically there will be a name change because it's a co-ratio. So cot of pi over 2 plus theta, remember, cot becomes, what does cot become? Tan. So I've got negative tan theta. Now whenever I've done a reduction, I like to put my final function in brackets so that I remember when I'm multiplying and I don't get confused between addition and subtraction. Now let's have a look at cosec pi minus theta. Go through my set of questions again. What quadrant does that lie in? Well, pi minus theta lies in the second quadrant. Is cosec positive or negative in that quadrant? Well, I know that sine of an angle is positive, therefore the reciprocal cosec is also positive. So I don't have to put that plus in, but I know I'm dealing with a positive cosec. Is there a name change? No, because I'm not dealing with pi over 2. Then the last question that I actually need to ask myself is, what is the acute angle? When we're dealing with a variable like theta or alpha or beta, it's automatically going to be my acute angle. So that last question comes into play more when I've got a numerical question. Okay, let's go to our denominator. Sec of 2 pi minus theta, again ask myself, what quadrant is it in? It's in quadrant 4. Is sec positive or negative in quadrant 4? Well, we know cos of an angle is positive, therefore its reciprocal sec is also positive. So now I'm dealing with positive sec theta. Great. Now I need to simplify, and at the moment nothing cancels. So I need to use my identities and my definitions of my reciprocals to rewrite everything in terms of sine and cos if possible. So let's use our quotient identity to rewrite tan theta, and we're going to have negative, now I can put that negative inside or outside the brackets, it doesn't really matter, sine theta over cos theta. I'm going to put it outside in this case. Then I can rewrite cosec theta as 1 over sine theta. And in my denominator, I can rewrite sec theta as 1 over cos theta. Alright, now you should see that things start to cancel out. I'm going to cancel out in green. So this sine theta and that sine theta cancel. So what I can do is write another step just so that you can see all the in-between steps. I've got negative 1 over cos theta divided by 1 over cos theta. Now when I've got a fraction inside of a fraction, I like to actually use just my normal divide sign. So divided by 1 over cos theta. Remember your tip and times. So I've got, just extend this a bit, I've got negative 1 over cos theta, I actually don't need those brackets anymore, times by cos theta over 1, And again, you can see that cancelling happening. So I'm left with negative 1 over 1, which is negative 1. And you're done.